In this video, we will discuss the problem subarrays with sum equal to k. The problem has been previously asked in companies like Microsoft. Let's discuss this problem statement. Problem says that we'll be given an unsorted array of integers and we have to find the number of continuous subarrays having the sum equal to k here. So if you will see the sample test case, let's discuss the sample test case that has been given to us. So there are two subarrays in this particular given array which are having the sum equal to k here, because if you see k value is 33, so the very first subarray that is having the sum equal to 33 is this particular subarray. And which is the other subarray which is having the sum equal to k? The other subarray which is having sum equal to k is basically the subarray which is having the elements 20 and then 3 and then 10, because the sum of this particular subarray is also equal to 33. So basically the count or the answer for this particular test case will be 2, because there are two subarrays which are having the sum equal. So that is what you have to return. You have to figure out that how many subarrays are there in this given array which have the sum equal to k here. Now what is the brute force approach of solving this problem? The brute force approach of solving this problem is by traversing all the subarrays, by checking all the subarrays and determining whether the sum of those subarrays are equal to k or not. If the sum of the subarrays are equal to k, you can increase your counter. So initially what I'll do is, I'll say that let's update the counter initially as 0 or the answer as 0. Let's update the answer as 0. You can take any variable here. Let's say you have your answer equal to 0. Now after that, basically initially you will start from this particular point here and you will say that you will explore all the subarrays starting from this particular index here. So basically which subarrays are there? If you'll observe, first subarray is only 9, then you have 9 4, then you have 9 4 20, 9 4 3, then 9 4 10, and then 9 4 5. So basically when we start from here, we'll try to consider every subarray starting from this point. So what will happen is, initially my starting will be from this particular index. Now when I'll take the sum, so my sum will be equal to 9 only. So initially I'm considering only this particular subarray. Is it equal to k? No. So ask your index to move forward. Now you'll be having this element as well, because we'll be running another loop. Now end point was here. Now this is the end point here. Now the sum of this element 4 also, the sum becomes 13. Is it equal to k? No. So this particular subarray 9 4 also does not have the sum equal to k. Now my e will move forward. Now e will move here, and if you see this particular subarray 9 4 and 20, it is having the sum equal to 33 here. So I'll update the answer as 1, because I have found out one subarray which is having the sum equal to k. Then after that, what will happen is my e will move forward and it will be here. Now the sum is 36. Is it equal to k? No. So update your e. Now e will be here. The sum will be 46. Is it equal to k? No. Now your e will be here. So we are considering this whole subarray starting from 9 till 5. Now if you see here, the sum is what? The sum is 51. Is it equal to k? A big no. So after this, what will happen is we have tried to explore all the subarrays which are starting from the 0th index. Now after that, my start pointer will move forward, and you can say that my pointer will be here, and we'll try to explore all the subarrays starting from the index 1. So we'll explore this subarray, then 420, 43, 423, 423 and 10, and then 423, 10 and 5. We'll explore all these subarrays and we'll check that if any subarray has 0 sum. So initially the sum will be equal to what? Let's write this. Initially the sum will be equal to 4 here. Then after that, when we'll include this element 24, it will be. Then after that, it will be 27. Then after that, it will be what? 37. After that, it will be what? It will be nothing but 42. So nowhere the sum was equal to. So in that case, I'll say that I'll need to move forward. So now my start will move forward and my start will be here. Now we'll try to explore all the subarrays starting from this index. Initially my sum will be equal to 20. Now after that, this particular subarray does not satisfy. Now we'll check for 20 and 3. So plus 3 will be done. End point will be here. Now plus 3 will be done. 23. It's not equal to k. Again will increase. Now the end point will be here. Now the sum will be equal to 33 here. This particular subarray 23 and 10, it is having the sum equal to k. So the answer will be updated to nothing but 2 here. And this way you will keep on checking. So basically from every starting index, you will explore all the subarrays. So you can see here, if I started from the 0th index, I'll explore the subarray from here to here, then from here to here, then from here to here, here to here, and so on and so forth. So basically I need another pointer e also. So you can say that I need two different loops. You can say those loops can be ij, or those loops can be S and E loops. So this is by doing this, I can explore all these subarrays. Let's have a look at the code here. If you will see here, what I can do is I can initially update my result or my answer equal to 0. And after that, we can have a starting pointer. You can say that our starting pointer is here, the index from which I'm going to explore all the subarrays, starting from that start index. Okay, then after that, initially my sum will be equal to 0, because if I have got this particular array here, let's say if I have got this particular array here and this is my starting point, so initially my sum will be 0, then I'll consider this element only, then this particular subarray, then this particular subarray. So as my e keeps on increasing, I'll keep on adding the elements here. Now after that, if you'll see, my e will start from S until the length of the array. So we'll explore all the subarray from the current starting index till the end of the subarray. till the end of the array, like this. And if anywhere the sum is equal to k, for any subarray, if the sum is equal to k, then you update your result by 1. Okay, and in the end you return the count or the number of subarrays that you have got here. I hope that this is clear. Now if you see the time complexity of this code, so the time complexity is very high. The time complexity is basically order of n square, because we are running two different loops nested one inside the other. The space complexity will be what? The space complexity is going to be constant order of 1, because I'm not using any extra space in this problem here. Can we do it more optimally? Yes. What we can do is we can use the concept of hash maps here. Now notice one more thing, that I have updated my test case, because initially we were using 9, 4, 23, 10 and 5. So I am using this test case, as well as I'll be using another test case. So I'll be using two test case to explain how this will be done using hash maps, and why we will specifically use hash map and not a set here, because we need frequency of a particular sum as well. Okay, so what we'll try to do is, inside the map you can say that with respect to the sum, I'll try to store its frequency, guys. Okay, this is something that I'll try to maintain here. Now what will happen here? See, initially, let's erase this sum here. The thing is, the whole idea is based on the concept that suppose if I have an array, suppose if I have this particular array here, and I keep on taking the sum till a particular point. Now suppose that at this point I have got a particular sum, and already whatever sums I have seen, I have stored them inside the map. Now what happens is, if I check at this point, I check whether sum minus k exists in the map or not. If I check that sum minus k exists in the map or not, and I am able to identify that yes, before this index there was a particular sum which was equal to sum minus k, this means that in between the subarray sum will be equal to nothing but k here. How and why, you will observe this when I'll do the dry run. So the main concept is that if currently I have this particular sum here, and sum minus k exists in the map. So if I have seen sum minus k already, this means that in between the sum of all the elements would have been equal to k here. Because what one thing that I'm trying to highlight here is, suppose that my k value is equal to 3, guys. Okay, now if as of now my sum is equal to 10, and if previously I have seen a particular sum which is equal to 7, if I had seen the sum as 7 earlier, and currently my sum is 10, and if I have seen the sum as 7, this means that in between the sum of the elements will be equal to 3 here, in between the additional elements that are there. If so far till this point the sum was already 7, and as of now here the sum is 10, and at this point the sum is 7, this means that in between these the sum of these elements will be equal to nothing but 3 here. I hope you got my point. Now let's discuss this using this test case here. So you can see here there will be another scenario when your sum is directly equal to k also, because when your subarray from the starting till a particular point has the sum equal to k, then also you can say that you can store or you can increase your answer. So initially you can see that my result variable will be there. Now my sum variable will get updated. Initially it will be 9. I'll check does the sum equal to k? No. Now after that I'll check, does sum minus k exist in the map? So 9 minus 33, does it exist inside the map? No, it does not. So I'll say that okay, let's update the element 9 inside the map with the frequency as 1 here. Now after that, the next time my sum will be equal to 13, cumulative sum will be equal to 13 here. Now when I'm at 13, it is not equal to k. I'll check 13 minus 33, that is minus 20 exists or not. Minus 20 does not exist. So I'll say that okay, no worries. I'll basically put this particular element 13 in the map and with the frequency as 1. Now after that my element will be equal to 33 here. Now if my sum is equal to 33, because the element was 20 and the sum became equal to 33, if the sum becomes equal to k here, what should I do? I should increase my result. So the result will be equal to what? It will be equal to nothing but 1 here. Then after this, what I can do is I can try to check whether 33 minus 33 exists or not. So sum minus k exists or not. It does not exist. 0 does not exist. So I'll say that okay, let's also put this element 33 inside the map with the frequency as 1. Then after that, what we will do is, next time my element will be 36, the sum will be 36, because the element is 3, sum will become 36. Now thus 36 minus 33, that is 3. Does the sum 3 exist? Have I seen the sum 3 previously? No, I haven't. So I'll say that okay, let's move forward. Now after that, when I'll take the sum of the elements, I'll get what? I'll get 46 here. The moment I get 46, as of now this is my sum. I'll check whether sum minus k exists or not. Sum minus k is what? 46 minus 33, it's equal to nothing but 13. Does 13 exists in the map? Yes, it does. How many times? Only one time. So you can see here 13 exists. This means that in between the sum of the elements, there is a subarray whose sum of elements is equal to k here, because if currently I have a particular sum, and before this sum, if I have seen sum minus k in the subarray somewhere before, so this indicates that in between the sum of the elements will be equal to k here. So you can see as of now, if I have a particular sum and sum minus k exists in the map, so this basically indicates that in between the sum of these elements will be equal to k. That is why you have this particular sum here. So how many times 13 is occurring? Only one time. So update your result by 1 more, and the result will be 2, because the frequency of 13 is 1. 13 is occurring one time, so update your result to 2 here. I hope you have understood this clearly here. Now after this will be at the next element, which is basically 5. So the sum will be 51. 51 is not equal to k, and 51 minus 33, that is basically equal to 18. Does 18 exist? No, it does not. So you can see that my iteration ends and my counter is equal to what? My result is equal to what? My result is 2, because there were two subarrays with the zero sum. So there is one thing you need to check, that if the sum itself is equal to k, then you can update your result, one thing. And otherwise, suppose that what happens is, you can say that else if my inside my map, if the sum exists, so sorry, inside my map, if sum minus k exists, this means that if the sum minus k exists, if as of now I have a particular sum and sum minus k exists, in between the subarray is having the sum as k. This is what we can identify. So whatever number of times sum minus k is existing, you can basically update your result with that. Why you should do this? Let's understand this using the second test case here. So we have this test case here. I have increased the size of this test case only. So you can see initially my sum will be equal to 9 here. Then after that my sum will be equal to 13 here. Then it will be equal to 33 here. Okay, and you know that for all these elements, sum minus k will not exist. Then after this, we are at 33. My result will get updated to 1 here, because this subarray is having how much sum? This subarray is having 0 sum. Sorry, this subarray is having how much sum? This subarray is having 33 sum. Then after that, I'll be at this particular element 36. Also in the map by this time, you know that 9 will have the frequency as 1. You know that 13 will have the frequency as 1. You know that 33 will also have the frequency as what? As 1. And when you're at 36, you will check that 36 minus 33, does it exist in the map? Does 3 exist? No, it does not. So put 33 inside the map with the frequency as 1 here. Sorry, 36 inside the map with the frequency as 1 here. Now after that, we'll go to the next element, that is 46. Does 46 minus 33 exist? Does sum minus k exist in the map? Yes, it does. 13 does exist. How many times does it exist? It exists only one time. So update your result by this counter. Update your result by one more. The result becomes equal to 2 here. Then after this, what will happen is you'll update the frequency of 46 as well inside the map with the frequency as 1 here. Then what happens next is you'll be at this particular element. So now the sum will be equal to 51. 51 is not equal to k, and 51 minus 33, that is 18, also does not exist. Okay, then we'll check for the next element here. Now we are at this element 28. So when I'm at this element 28 here, what will happen? The sum will be equal to nothing but 9, 79. Now I'll check whether 79 minus 33, that is basically sum minus k, which is equal to 6 and 36. Does 36 exist? Yes, 36 does exist. This means that in between the sum of the elements will be equal to k here. So update your counter by the frequency of 33. 33 is occurring how many times? Sorry, 36 is occurring how many times? 36 is occurring only one single time. So update your result by this. So update it by 3. If 36 would have occurred 2 times, then they would have been 2 subarrays. So depends on the frequency of the element here. I hope you have understood this clearly here. Now let's try and see the code also. If you will see here, we need to first of all maintain a map here. You can name it as MP, or you can name it as prefix sum map also. Now after that, what we will do is we'll update the result as 0. Initially the current sum will also be equal to 0. We'll iterate in the elements of the array. We'll take the sum of the current element, and if the sum equals to k, then we need to update the result, because if from the starting till the ith index, if the subarray is having sum equal to k, then we need to update the result. Otherwise, if inside the map current sum minus k is present, then we need to update the result with whatever number of times current sum minus k is present. Because if suppose that as of now I have got the sum as what? Suppose that, as I said, if my k value was 33, and as of now my sum is equal to 46, and the sum minus k, that is value 13, is present 2 times. So this means this particular subarray will be there and this particular subarray. So there will be 2 subarrays which will be having the sum equal to k. So whatever is the frequency of sum minus k, you have to update your result with that. And then after that, you can increase the frequency of this particular current sum inside the map. At the end, just return your result here. Now what is the time complexity for this approach? The time complexity for this particular approach is going to be order of n here, because we are going to linearly iterate throughout the array, and the space complexity will be what? It will be order of n, because I'm going to use extra hash map for solving this problem here. Now let's try and submit this code also. So let's try and submit this code and check if it is getting accepted or not. You can clearly see that the code is getting accepted. I hope that you have understood this problem clearly. Make sure to comment understood, and thank you for watching this video.